All right, now we are going to build the next part, which is the tools. Okay, so in tools we're going to build the search tools.py. Okay, what is search tools.py? This file defines the tools that our LangGraph agents are going to use, and these tools are going to interact with the database, with the memory layer, and the vector search system or the vector database. Okay. Now, as you may know, when it comes to agents, why do we need tools? Because tools are the ones that performs action for a particular agent, right? Uh, Here, tool is a function that an agent can choose to call. Okay, an agent does not call the tools directly in the code. Instead, GPT-4 will decide which tools to call based on what it is trying to find out. Okay. For example, it is going to call tool 1 if it wants to search the evidence database by meaning. It is going to call tool 2 if it wants to look up of what I have what I found about this sponsor before, and tool 3, okay, so on and so forth. So every agent is going to perform a particular job. Now if you see here, we have defined 3 separate files: search tools, PubMeds, and clinical tools differently. Why are we defining them separately from the agents? We just want to do a clean separation. The simple reason being, tools know how to fetch the data, okay? Then agents know what to look for and how to reason about those findings. These tools that you're building, they are reusable, which means multiple agents can use the same tool, okay? How does LangGraph tools work? We're going to use something called as the tool decorator, okay, that transforms a regular simple Python function into a tool, okay, and reads the function's docstring to understand what the tool does. Okay, so we're going to import a couple of files, the same files, okay, from langchain core.tools. We're going to import tool, we're going to import vector store, episodic search store or episodic store, and semantic store. We're going to set up the login, and now we're going to set up some shared store instances. Okay, we create one instance of each store at the module level. Module level means outside any function or a class. And why are we creating one shared instance? We're creating a new database connection pool for every tool call. That would be extremely wasteful if we do so, right? So opening a connection roughly takes 100 to 200 milliseconds, and with 6 agents and with 5 to tool calls per run, that is 30 to 60 connection openings per analysis run, and this is going to introduce a lot of latency. We don't want that. Instead, we create one instance per store, okay, at the startup. Okay, so here we're just going to initialize vector store. We're going to create one shared vector store instance, okay, then one shared episodic store instance, and one shared semantic store instance. We're going to create all these 3 instances. Okay, then LangGraph tools are actually called synchronously by the framework. Okay, now LangGraph doesn't use await tool functions, but all our store methods, these shared store methods, they are all async in nature. Okay, and this is where there is a conflict. Okay, so in this case, we are going to use something called as run async, which is a helper that runs async function synchronously by using async IO. Okay, so we're going to use async IO.get event loop. What does this do? It gets the current async event loop and run until complete using coroutine, which is we're going to run the coroutine and wait for it. Now what is coroutine, we'll understand. Here if you see, I'm creating a function called as run async on coroutine. Okay, it runs an async coroutine simultaneously. What is coroutine? It means that when you call an async function without await, Python gives you back a coroutine, which is a suspended function that has not run yet. For example, For example, if I'm saying result equals to, apologies for that. For example, if I'm saying result equals to store.search, okay, coroutine has not run yet. If I'm saying result equals to await store.search, actual result, okay, this is the actual result which is ran and waited. Okay, what is coroutine? Again, we're trying to understand that our Python gives back a coroutine, a suspended function that has not been run yet. Okay, this helper takes a suspended coroutine and runs it to completion using the event loop. Okay, that is what we're going to do here. So at an argument level, what we're going to take? We're going to take coroutine, which is an unawaited async function call, and what does it return? It returns whatever the async function would have returned with await. Yeah, so I'm going to say async io.get event loop. Now here this get event loop returns the currently running async IO event loop. Okay, the event loop is the engine that manages all the async operations. Now these things might be a bit new for you. Okay, as of now this is out of scope, but if you're not comfortable, I would highly request you guys to please first get comfortable on async operations and then kind of follow. Okay, that will be super helpful, because these async operations and stuff are super important when you're building production level capabilities. Okay, so here the event loop is the engine that is going to manage all your async operations, and LangGraph runs inside the event loop, so there is always one available. What does it return? It returns loop dot run until complete with the coroutine. Okay, it takes the coroutine and runs it inside the loop. It waits for it to finish and returns the result. Okay, and this is nothing but the bridge between the synchronous, which is LangGraph tools, and the asynchronous, which is the database functions. Okay, we are going to implement now in this file, which is search tool. We're going to build around 4 to 5 tools. So let us look at each and every tool. Each and every tool is nothing but a simple Python function that is doing a particular job. Okay, so tool 1, which is search studies by meaning. Now from the name itself, things might be very self-explanatory. Here we are using tool decorator, and what this tool decorator will do, it will just convert our simple Pythonic function into a usable tool. Okay, now this tool, which is search studies by meaning, takes in the query, top k parameters, and source filter as of now, which is set to study. And what does it return? It returns a string. What is this string? It basically means that the tool must return strings for LangGraph. When we are talking about source filter, it is study or paper. Now by default it is study, which means it is either research study or research paper. By default we are setting it to research study. Okay, query, as in the GPT-4o, passes the search question as a string. So what does this function do, or this tool do? It serves the clinical trial studies using semantic search similarity. Okay, it uses this tool when you need to find the studies related to specific topic, condition, sponsor behavior, or research integrity issue. The search works by meaning and not by exact keyword matching, so it is going to do vector search. Okay, yeah. Okay, finally what does it return? It returns a JSON string that is matching the study chunks with similarity scores. We finally log it. We're just going to understand which tool we have called. We're going to look at the first 60 characters in the query and the number of chunks it used. Okay, now in results we're going to use the run async function, and inside the run async we're going to use vector search on the query. Okay, we're going to use vector store. This is the shared instance dot search basis the query that is given by the user. So vector store dot search will embed this text and find the most similar chunks. It is going to take top k parameters. It is going to take the source filter, which is study by default, and run async that we have used here, that runs the async search method synchronously, which means the result is a list of dictionaries, each containing whatever the chunk text, NCT ID, similarity scores, all of that. In case if there are no results to be found, it just returns a clear message, a JSON string which has results, message, and query, basically nothing. Okay, and finally what does it return? If it works, what does it return? It returns a JSON list which contains the result, which is the list of matching chunks with the similarity score, count as to how many results came back which are useful for the agent to know that it got the full top k or fewer, the query given by the user, and we're going to just set the indent so it is readable. So this is what we get in the output, and this is where we log the exception. We go to the second tool, which is search past episodes. We're going to create the tool called a search past episode. Again, it takes in the query, takes in the agent name, top k parameters. What does this tool do? This tool is going to search through past agent reasoning sessions, this tool is going to interact. Search past episodes is going to interact with the episodic memory. Use this tool at the start of any investigation to check if they have found similar signals before. This prevents duplicate work. So ask questions like, for example, previous findings about missing results, past investigation of a particular research study, episodes where outcome switching was detected. So it is going to look into your past episodes. These are the arguments that it takes. This is what it returns. It returns a JSON string with the most relevant past episodes. If you can recall, we had defined, when we were defining episodic memory, we defined accordingly, right? We wanted the most, we had actually created a private method which gives us the most relevant episodes, recent episodes I would say, not relevant. And we're going to finally log it here, which means which is the tool called, what is the agent name, and what is the query used. Okay, then again we're going to use the same run async. Okay, we're going from the episodic store we're going to search the episode. This is the query, agent name, and the top K. Okay, and if there are no episodes, it is going to return as an empty JSON, or else it is just going to return a JSON script or a JSON string which contains the episodes, a list of episodes, okay, count, and which is how many episodes, and the query asked by the user, and we log the exception here. Then we go to the next tool where we're going to save the episode. It is again self-explanatory. This also works with the episodic memory. It takes the agent name, content, NCT ID, which is as of now like we are setting to none basically, and outcome we are going to set it by default to completed. Okay, we're going to call this tool at the end of investigation after you have drawn the conclusions. So saving episodes builds your long-term memory. Okay, we write the content as detailed case. Now when we are talking about content here, what does content mean? Content means what study you investigated, what's the sponsor's behavior was, what signals you found, and why you reached a particular conclusion. This is the arguments that it takes into consideration. And what does it return? It returns a JSON string. So you can see the same thing, run async, then in episodic store it is going to save the episode, it is going to work on these IDs, these arguments. Finally, what does it return? It returns you a JSON, okay, which contains success, true or false. Have you got the past, have you saved the episodes, true or false, takes the episode ID, gives you the message and the agent that you used, yeah, or else if it's exception, it is going to log that as well. Then you go to tool 4, which is get sponsor profile. What does this do? It retrieves everything the Mosaic or our Agentic or our AI agents knows about a specific research sponsor. We're going to use this tool when evaluating a study to understand the sponsor's historical behavior, their compliance record, broken promises, everything. When the credibility score is low, it is concerning. If it is below 0.4, it is a serious red flag. Sponsor name is nothing but the name of the company or the research institution that is funding the research. And what does it gives in return? It returns a JSON string with the sponsor's full profile. If you see here, again, from the semantic store, we are going to get the sponsor profile basis the sponsor name. Okay. If the profile is none, it is going to return as empty or false. And if not, then what does it return? It returns a JSON string which found as true. It returns the sponsor profile and it logs the exception if in case, yeah. If in case there is an error, it is going to log it. Final tool, update sponsor profile. Okay. What does this do? It takes sponsor name into consideration, result posted. Now default it is set to false, had broken promise set to false, and delay number of days as of now 0. What this is going to do? It is going to update the sponsor's profile with findings from the current study. It is going to call this tool after you have analyzed a study and determined whether the sponsor posted the results, true or false, whether the outcome switching was detected true or false, how many days late the study was, and 0 if it was on time. And this update accumulates in the sponsor's profile permanently, and the future agent sessions will see this updated credibility score. This is what it takes into argument. This is what it returns, a JSON string confirming the update was applied. Yeah, we are logging it here, and you can see we are using semantic store. In semantic store we are using update sponsor knowledge, and these are the things that we will be recording or considering, taking into consideration. Yeah. Finally, what does it return? It returns a JSON dump, okay, with success as true, sponsor name, message, which is sponsor profile has been updated successfully, results posted, had broken promise, and delay days. This is what it gives us in the JSON dump. Coming to tool 6, which is low credibility sponsor. This tool helps us interact or get all the sponsors with credibility scores who are below the threshold. Okay, so you can see we have set the default threshold to 0.6 and minimum number of studies to 3. Okay, it returns a JSON string listing all the low credibility sponsors with their profiles, and it is empty if sponsors are above the threshold. Okay, so you can see again from the semantic store we are going to apply get low credibility scores. It is going to take threshold and minimum studies. If not, sponsor returns an empty JSON, and then or finally it returns a JSON which gives us the sponsors, the counts and the threshold, and it logs the exception. Or else we are going to have one more tool which is search study chunks by NCT ID. Okay, it is going to search the study chunks basis the NCT ID. You can see it takes the NCT ID and the query taken. Okay, what does it do? It retrieves all the text chunks for one specific study by NCT ID. We're going to use this tool when you already know which study you want to examine in detail and need its full context. It is different from search studies by meaning, which is I think our first tool, which searches across all the studies. This tool gets full content of one specific study. It takes into consideration at an argument level NCT ID and query. What does it return? It returns a JSON string. Okay, so you can see in case if you give a query from the vector store, it is going to take the query text, basically it is going to search from the vector store, the basis the query text, top 5 and NCT ID. Else it is just going to, from the vector store, it is going to get the chunks for study basis the NCT ID. Okay, in case if there is no query, just get all the chunks, that's all. Okay, if no results, then it is going to give you empty JSON. If things are fine, then it is going to give you a JSON dump which contains the NCT ID of the research, chunks, counts, okay, which are how many results it got, else it is going to log the exception. Finally, coming to the last tool in this particular file, which is search papers by meaning. Okay, it takes the query and the top K. It is going to search the PubMed research papers using semantic similarity. Okay, we're going to use this tool when you need to find published research papers, okay, which is related to a specific topic. Now again, this is different from search studies by meaning, which searches all the clinical trials finding. Okay, now this is not looking for clinical trial filings, it is looking for research papers. This one, search papers, as the name suggests. Again, the same job, it's going to do the same job here. And finally, what does it return into JSON? It gives a JSON output of results, count and the query. Finally, what do we do towards the end? We have built 8 tools in one file itself, which is search tools, right? We're going to do tool registry here. Now this is called as tool registry, which means I can access now all search tools. If you see whatever tools we have defined, we are passing all the tools here in a list format. So all search tools is a Python list containing the tool functions, and we export this list into a file. Okay, so graphbuilder.py imports it. Now from, if you see in graphbuilder.py, when we'll be building it, we'll be using this command from tools.search tool import all search tools, which means when we'll be building the LangGraph, the final graph, we need all these tools into consideration. So we cannot type it one after the other. So we're just going to call all search tools, which is going to access all the tools at one single shot. Okay, and this is called as tool registry, as simple as that. Okay guys, so that was searchtools.py, where we built different 8 kinds of tools, all of them having their own specific meaning. Okay, I hope you liked it. Let's move to the next part.